Thank you very much for your patience. Now we'd like to resume. The next session's title is Computing Infrastructure for the AI Era. The speaker is Ms. Sachiko Onishi, Executive Member of the Board, Executive Vice President, CCXO, and Co-CAIO of NTT. Ms. Onishi, the floor is yours. Good afternoon, everyone. Thank you for being with us today. I believe you now understand the necessity and potential of the NTT Ion Photonics Electronics Convergence device Spec 2 as a low power consumption device required in the AI era. And lastly, I'd like to share my thoughts on how we can realize a computing infrastructure that supports the AI era through this low power device Ion Spec 2. So why does the expansion of AI usage continuously lead to increasing power consumption? The graph on the left compared the power consumption of conventional servers with that of GPU servers, which provide the computing resource required in the AI era. The power consumption of GPU servers needed for AI is approximately 5.9 times higher than that of conventional servers. The graph on the right shows the trend in the number of GPUs, which require that 5.9 times higher power consumption. The number of GPUs is increasing at the rate of 1.8 times per year. This is why the expansion of AI usage inevitably results in a continuous increase in power consumption.
This is showing the data center's power consumption. The red line at the middle is showing the Tokyo's total power consumption by 2030. With the advancement of AI, if this continues, by 2030, the data center power consumption will exceed the total Tokyo's power consumption. If this trend continues, the rapid increase in electricity consumption driven by the expansion of AI usage could become so severe that it might impact our daily lives, potentially leading to situations like planned power outages. Another aspect is the rapidly increasing cost burden on users due to AI utilization. The graph on the left shows the annual AI-related budget amounts for companies. Costs for fiscal year 2025 are projected to increase by 75% next year. And while AI usage expands, concerns about a declining ROI are also emerging. While the cost breakdown, please look at the graph on the right. This is showing the AI adoption. This shows the composition of AI market consisting of three major areas: consulting, application, and infrastructure, such as GPUs and data centers. Among this infrastructure domain, including GPUs, accounts for the largest, over half of total. Computing infrastructure, such as GPUs, is driving the rapid increase in power consumption and cost growth. So in this sense, given the situation, two major points are required for the computing infrastructure supporting AI utilization, that is reducing power consumption and cost through efficient operation and reducing the power consumption of the devices that make up the infrastructure itself. ION is a key component that enables the simultaneous achievement of AI utility, efficient operation, and reduced power consumptions. First, let me explain the efficient infrastructure operation. As AI usage expands into various business processes, changes are occurring in the utilization rates of computing resources like GPUs. Even when building GPUs resources individually for specific AI applications, as one done in the past when AI usage was limited, they function at relatively high utilization rate. However, as AI adoption expands across diverse industries and various business functions such as finance, legal, and marketing, and when GPU is composed per how it is used as shown on the right graph, it leads to inconsistency in utilization rate. In fact, when examining specific time periods, there are instances where only 50% of the total GPU resources are utilized. Furthermore, with the increasing demand for computing infrastructure like GPUs, power supplies is reaching its limits, especially metropolitan areas. This necessitates distributing GPUs to regional data centers with surplus power capacity. While the ideal would be to efficiently operate GPU resources for various AI applications within a single cluster at one location, the reality is that power supply limitations are driving the decentralized deployment of computing infrastructures like GPUs. Leading companies are already utilizing multiple large-scale AI models, just as generative AI, image analysis, and real-time processing, alongside the expanding scope of AI applications. Consequently, thousands of GPU resources are required for AI training and inference. Consequently, companies have already distributed GPU installations and are visualizing GPU usage costs and power consumptions at each site, and are beginning initiatives to efficiently manage distributed GPU resources, such as assigning a more demanding AI processing to locations with surplus power or GPU resources to efficiently manage distributed GPU resources. The first requirement for computing infrastructure supporting the AI era, which is efficient infrastructure operation, is achieved by connecting the vast distributed GPU resources at high speed via IO-APN, effectively creating a single massive computing platform virtually. Depending on the application and usage conditions, it flexibly optimizes the allocation of distributed computing resources like GPU and assign resources to sites capable of supplying the necessary power based on GPU load and power consumption, ensuring stable and efficient operations. Next, I will address another requirement, reducing the power consumption of the equipment that constitutes the infrastructure itself. As AI processing volume increases, the number of required GPUs also increases, leading larger capacity of internal computer communications. The bottom diagram shows the configuration of NTT Data's GPU as a service used as the training environment for NTT's LLM Tsuzumi. It may be difficult to see it significantly scaled down like this, but you can probably imagine the large amounts of communication occurring within the computer from the numerous capables wiring. The diagram on the right, which was also shown in Ms. Hoshino's explanation at the beginning, presents communication volume, the vertical axis, and communication distance on the horizontal axis. As you can see, communication exceeding 10 terabits per second, even within a computer where components are extremely close together, faces barriers with increased power consumption and heat generation, and electrical communication has reached its limits, necessitating to shift to optical communications. While the processing demands AI usage and increase in GPUs, internal computer communications have already reached the terabyte level. Electrical methods have reached their limit, making time for ion photonics devices to step up. The second requirement for computing infrastructure supporting the AI is reducing power consumption as the infrastructure itself, as shown in the diagram on the right. Implementing this PAC device, PAC2, in the switches connecting components within the computer enables both increased communication capacity and reduced power consumption. The utilization of AI is steadily progressing. The line graph here shows that since 2023 and November, NTT announced its LLM model. The number of inquiries from domestic companies regarding Tsuzumi and AI-related matters have been steadily increasing, exceeding 1,800 cumulative cases. Additionally, the bar graph shows that orders related to generative AI have exceeded 1,800 cases combined domestically and internationally. Alongside this steady progress, inquiries regarding the construction and operation of computing infrastructure supporting AI utilization, such as data centers, cloud services, and GPU as a service, are also increasing. The NTT Group provides GPU as a service, a managed service that delivers the necessary computing resources at the require time and scale tailored to specific AI usage scenario. The ability to deliver secure and efficient operation and provision of GPU servers, storage, resource management, security, and other resources required for AI utilization efficiently and securely is leading to the previous shown screen of AI orders. The mobility AI platform we jointly announced with Toyota last October to realize society with zero traffic accidents requires massive GPU resources. In addition to Toyota's existing computing resources, we plan to build NTT Data's new GPU as a service and deploy it in a distributed manner with an efficient operation, and power reductions are going to become key. To sustainably and widely deploy the benefits of AI, the computing infrastructure for the AI era must have efficient operation and reduced power consumption, connecting the increasingly distributed GPU resources via ION APN, and with the low power consumption device, the PAC switch, we will take the challenge of reducing the power consumption of computing infrastructure as well. Thank you very much for your kind attention.